back at the elite sports cars of the 1980s and 90s, you'll find machines that were gorgeous, aggressive, and incredibly fast. But if you actually wanted to drive one to work on a Tuesday, you were in for a rough time. The industry operated on a widely accepted compromise. To get elite, high-performance engineering out of a European exotic, you had to accept extreme fragility. These cars would famously overheat in stop-and-go traffic. Their clutches required massive physical effort to press, and the rear visibility was often so poor that parking felt like a guessing game. Then, Honda decided to build a mid-engine exotic. Their goal was highly specific: engineer a car capable of beating elite European standards on the track, while remaining as reliable and easy to start as a standard commuter sedan. When the Acura NSX debuted, it challenged the unwritten rules of exotic car manufacturing. It proved that peak track performance and daily usability could exist in the exact same chassis. The engineering philosophy for the first-generation NSX, running from 1990 to 2006, was ambitious. Honda wanted to embed the advanced technology they were using in their dominant Formula One cars directly into a comfortable, street-legal package. To pull this off, they built the world's first mass-produced all-aluminum production chassis. Replacing heavy steel with an aluminum skeleton allowed for a level of agility that traditional frames simply couldn't replicate. This animation illustrates the heart of the NSX, a naturally aspirated V6 paired with Honda's VTEC system. VTEC stands for Variable Valve Timing and Lift Electronic Control. As you can see, pins lock into place at higher speeds to engage a more aggressive camshaft profile, allowing the engine to pull in more air and fuel. Looking at this power curve graph, you can see exactly why VTEC was so vital. The line remains flat and stable at low RPMs, ensuring smooth, predictable behavior during a daily commute. But once it hits that high-end RPM range, the power output spikes dramatically for track-level speed. But raw mechanics only go so far without the right tuning. During the final testing phases at the Suzuka circuit, Honda brought in Formula One legend Ayrton Senna to evaluate the car. Senna pushed the prototypes to their absolute limits and reported that the frame felt too flexible. Based on his brutal track sessions, engineers went back and stiffened the NSX chassis by 50%, elevating its handling from merely excellent to world-beating. By combining an ultra-light aluminum skeleton, a high-revving VTEC engine, and Senna's exacting track feedback, Honda created an analog machine that could dynamically outmaneuver the heavier, high-horsepower domestic competition of its era. Fast forward to the 2010s. The rest of the industry had caught on, and the everyday supercar was becoming a standard. For Acura to disrupt the market a second time, they moved away from the analog simplicity of the 90s and toward a radically different engineering strategy. The second generation entirely abandoned their original philosophy of pure lightness, shifting instead in favor of hyper-complex digital engineering. Instead of a naturally aspirated engine, the new NSX utilized a twin-turbo 3.5-liter V6, and they didn't stop there. They paired that gas engine with advanced hybrid technology to push the car's output to roughly 573 horsepower. This wireframe model shows how they laid out the Sport Hybrid Super Handle all-wheel drive system. You have the internal combustion engine sitting in the rear middle with one electric motor attached to it, plus two completely independent electric motors powering the front axle. This setup was never about fuel economy. Watch the power flow arrows here on the front wheels. The system can aggressively apply braking to the inside wheel while simultaneously accelerating the outside wheel, vectoring torque in real time to physically pull the car through tight corners at impossible speeds. To guarantee the precision of this complex system, Acura shifted manufacturing to Honda's specialized Performance Manufacturing Center in Ohio, cementing the second generation as a distinctly American-built supercar. This era culminated in 2022 with the release of the limited-run Type S. It featured the highest output ever offered and served as the final chapter for the gasoline hybrid generation. While the first NSX taught the automotive world how to mass-produce aluminum performance cars, the second generation proved that electric hybrid motors could be wielded as blunt force tools for raw speed and cornering grip. By proving a supercar could be as reliable as a Civic, the NSX shifted the expectations for the entire segment. It meant the temperamental nature of the Ferraris and Porsches we saw earlier was no longer an unavoidable trait of high performance, but a flaw that buyers would no longer tolerate. Today, an exotic car that strands you on the side of the highway is no longer acceptable. Honda's unusual idea of a practical exotic is now the baseline expectation for anyone dropping six figures on a sports car. The two generations of the NSX used completely opposite tools to get there. One relied on pure, lightweight analog mechanics, while the other utilized complex digital all-wheel drive. Yet both managed to catch the rest of the industry completely off guard. And Acura has dropped hints about what comes next, suggesting a fully electric or electrified successor could arrive later in the decade. Regardless of what powers the next version, the ultimate legacy of the NSX nameplate is irrefutable. It proved that achieving peak performance on the track never has to demand a compromise on your drive home.